We'll talk now about another property of alcohol, which is solubility. And of course, it has very dependent on the structure. So say solubility in water, for example. So now if you have a structure such as, say, this, and that's just ethanol, 2 carbons. Now we have talked before about type of intermolecular forces. Here you have, of course, London dispersion forces, the weakest present in most molecules. We also have a dipole here. There is a polar bond between carbon and oxygen, and this is also a polar bond. So we have dipole, and we also have a hydrogen bond. And we have talked before that the strongest of those interactions in this are, again, intermolecular forces, the strongest being the hydrogen bond. Now, if you're trying to dissolve that in water, water has a similar structure. Let's draw in the sense that it has that OH. So it also has the capability of hydrogen bonding within molecules of water. But this interaction is important now between, say, ethanol and water. And we can have a number of those interactions with water. So because of these properties being similar, this molecule being polar, that's polar, and also having the same type of interaction, ethanol is actually freely soluble in water. But there is a cut to that. So up to, say, 4 carbons, this molecule is also soluble in water. But as we increase the number of carbons, say now we have 4, as opposed to 2 that we have here. When we go to pentanol into higher alcohols, the insolubility decreases. And actually, butanol is like borderline, pentanol is not so much so. So you would be seeing, say, separation of phases if you do this in a test tube, for example. So this region we're going to call hydrophobic region. That means doesn't like water. It does better with non-polar substances, for example, to the soil. This part we're going to call the hydrophilic. And so as the molecule of alcohol increase in size, and now let's throw something much larger. Now we have here 1, 2, 3, 4, 5, 6, 7 carbon. That is insoluble in water. And it is because now the part that is hydrophobic is much larger. So it, say, relative weight, this way out more. So actually this compound is more hydrophobic than it is hydrophilic. It will be then insoluble in water. So this property is important and has been used in the design, for example, of disinfectants, the thing you wash in your hand, to lotions to eliminate germs. And the fact is that you can kill germs because there is a compromise here to penetrate in the microbe membrane, and it does because this compound having a long carbon chain are hydrophobic, so they can penetrate the lipid bilayer in microbe membranes, and also act then as disinfectants when they are again in. So now again, solubility will depend on intermolecular forces, and that size matters. So it's not only that this has an OH and will form hydrogen bonding, but actually if this part is has more, say, than 4 carbons, then it will be likely insoluble in water. And so for 1 to 3 carbons, freely soluble. So methanol, ethanol, and propanol. So again, intermolecular forces is what we're going to be using to explain solubility in water.